Hello and welcome. Today we're going to be looking at the October-November 2024 paper that's 9709/13. I hope you're going to learn a lot from what we're going to be discussing today. So let's get right into it. All right, so we are starting with question number 1, and it says, an arithmetic progression has fourth term 15 and eighth term 25. Find the 30th term of the progression. All right. So here we've got an AP and the fourth term, which we can write as A plus 3D. They say that it's 15. All right. And the eighth term, which is A plus 7D, they say it's equal to 25. So they want us to find the 30th term of the progression. All right, I'm going to call this equation 1 and this one equation 2. And we're going to say here equation 1 minus equation 2. Or rather, let me put it as equation 2 minus equation 1. So if we subtract the 2, A minus A is 0, 7D minus 3D is 4D, and 25 minus 15 is 10. All right, so dividing, okay, if this is 10, dividing both sides by 4 gives us D to be equal to 2.5. Now, if D is 2.5, if we take any one of the equations, say we take equation 1, we can use that to get the value of A, where we'll be saying that A will be 15 minus 3 of D, but D is 2.5A, so it's like 15 minus 7.5, which is 7.5. All right, so for us to get the 30th term, according to what they ask here, they say we should find the 30th term. Okay, I'll say here, therefore, the 30th term, which will be A plus 29D, will be equal to A is 7.5 plus 29D. So that's 29 of 2.5. All right. So if we do the calculation here, we will get the answer as being 80. So that's how we do it here. Let's move on to number 2. On number 2, the question says, find the exact solution of the equation cos of a sixth pi plus tan 2x plus root 3 over 2 equal to 0 for values of x ranging between minus a quarter pi and a quarter pi. All right. So in this particular case with this equation, we know that cos of a sixth pi, that's like cos 30, is actually root 3 over 2. And that's plus tan 2x plus another root 3 over 2, that's there already, equal to 0. So that means that tan 2x is equal to, and adding this 2 and moving them over to the other side, we will be having minus root 3, because root 3 over 2 plus root 3 over 2 is 2 of root 3 over 2, which technically is root 3. Right, so with what we have here, we are going to find the fundamental angle, okay, alpha, which in this case would be arctan of root 3, all right? Now, arctan of root 3 is actually 60 degrees, which is pi over 3. So if we consider the quadrants here, all right, we know that tan is negative. Okay, tan is positive in this quadrant and this quadrant, in the first and third quadrants. So it is negative in this quadrant and in this quadrant. Okay, that's where it is negative. So those are the two quadrants we are working with, and alpha will be having a value, and is the angle that these lines I've drawn makes with the horizontal. So alpha here and alpha here, which in this case alpha is pi over 3. All right, so there are two possible solutions. The first one read in this way, which is pi minus alpha. And we also have another angle, which is minus alpha because we're going clockwise. So that's minus alpha like this. All right. So we are therefore saying that 2x is equal to pi minus alpha, which is pi minus pi over 3, which is 2 pi over 3. The other value is minus alpha, which in this case would be minus pi over 3. All right. Now, dividing by 2, we get x to be pi over 3 and minus pi over 6. All right. Now, of this two, we know that this one would be out of range because pi over 3 is not a value between minus a quarter pi and a quarter pi. It's actually greater than a quarter pi. So the only answer that will remain is minus pi over 6. So therefore, x is equal to minus pi over 6. That comes out to be the answer. So that's how we do it for this one. Let's move on to question number 3. It says, find the coefficients of x to the 3 and x to the 4 in the expansions of 3 minus ax to the power 5, where a is a constant, and give your answer in terms of a. All right. So in this particular case, we are looking at terms, the coefficients of x power 3 and x to the power 4. All right. So for these, let's start with the term in x power 3. Now, the term in x power 3 in the binomial expansion would be the term 5, choose 3, all right, of 3 to the power of 2, and that's of minus ax to the power of 3. So that is the term in x power 3, and I've taken that from the binomial expansion of a plus b. So I think you can see here that the term in x power 3 would be a term represented by this part of the expansion. So n is 5, so that's why we're saying 5 choose 3, and 3 to the power 2 and minus ax to the power of 3. All right. So this should simplify to here 5 choose 3 is 10, and 10 times 3 squared, that will be 90. So here we'll be having minus 90 a cubed x cubed. So therefore, the coefficient of x power 3 should be minus 90 a cubed. All right. Now for the term in x power 4, it should be 5 choose 4 of 3 to the power of 1 of minus ax to the power of 4. All right. And this should be equal to 5 choose 4 is 5. So 5 times 3, 15. So 15 a to the 4 x to the power 4, which therefore means that the coefficient should be 15 a to the power of 4. So this is what we're getting for this one here. On part B, they say, given that the coefficient of x to the power 4 in the expansion of ax plus 7 of 3a minus x to the 5 is equal to 240, find the positive value of a. All right. So they're saying here that the coefficient of x power 4, right? So to get a term in x power 4 here, we should have ax multiply a term in the second bracket, which is a term in x cubed. So that's where we'll get a term in x power 4. And 7, when it multiplies the second bracket, it should multiply a term in the expansion in x power 4, basically. All right. So that's how we get a term in x power 4. So that would be ax of, now the term in x power 3, the term in x power 3 in the expansion of 3 minus ax power 5, we already got it to be minus 90 a cubed x cubed. So minus 90 a cubed x cubed. Okay, and that's plus 7 times a term in x power 4 in the expansion should be this 15 a to the power 4 x power 4. All right, so 15 a to the power 4 x to the 4 like this. All right, so this is going to be minus 90 a to the power of 4 x power 4 plus 7 times 15 is 105 a to the 4 x to the power 4. And minus 90 plus 105 is 15, so it's 15 a to the 4 x to the 4. So for the coefficient of x power 4, we'll be saying that's 15 a to the power 4, and that's the one they're saying is equal to 240. We divide both sides by 15, and a to the power 4 will be equal to 16 when we do that. And if we do fourth root here, we'll get plus or minus the fourth root of 16, all right? So a comes out as plus or minus 2. However, they say that we need the positive value of a. So therefore, a is equal to 2. And that's the answer here. Let's move on to the next question, number 4. It says, solve the equation 4 sine to the 4 of theta plus 12 sine squared theta minus 7 equal to 0 for values of theta ranging between 0 and 360 degrees. So we have 4 sine to the 4 of theta plus 12 sine squared theta minus 7 equal to 0. I will let u be equal to sine squared theta. So therefore, it will now be 4u squared plus 12u minus 7 equal to 0. Now this quadratic can be factorized. Here we can have 2u and 2u, 1 and 7, and then that's 2 minus 14. So minus here and plus here. All right. So the possible values of u there then are a half, or u is equal to minus 7 over 2. All right. Now, it then now follows that sine squared theta, which is u, can be equal to a half, and sine squared theta is equal to minus 7 over 2, of which here there will be no solution. Okay, no real solution because we don't have a real square root of a negative number. All right, but for this part, we will square root both sides and we'll get sine theta is equal to plus or minus 1 over root 2. All right. Now we're going to look for the fundamental angle by saying arcsine of 1 over root 2. So we do ignore the sign for now, all right? So alpha is arcsine of 1 over root 2, which is 45 degrees. Do they want it in degrees? Yes. They say 0 to 360, all right. And what that means is if we go to the quadrants, it actually means that alpha should have values in all the quadrants. Okay, it should have a value in all the quadrants. And the reason for that is because sine is both positive and negative. All right. So we'll have alpha here. We have alpha here. Alpha is always an angle between those lines and the horizontal. So essentially, the question is saying we should solve the equation, and it's for values of theta between 0 and 360. All right, so the first value would be this one here. All right, let me place it here. This angle, which in this case is alpha. So the first value of theta is alpha, which is 45 degrees. The next value is this angle here, which is 180 minus alpha, 180 minus 45 is 135 degrees. The next one goes all the way to this line, and it's alpha plus 180, which is 225 degrees. And the last one will go all the way through to here, and that's 360 minus alpha, which is 315 degrees. So these are the solutions, and that's how we do it. So on question 5, it says, in the diagram, the graph with equation y is equal to f of x is shown with solid lines, and the graph with equation y is equal to g of x is shown with broken lines. So on part A, describe fully a sequence of 3 transformations which transforms the graph of y is equal to f of x to the graph of y is equal to g of x. All right. So we have y is equal to f of x being transformed onto y is equal to g of x. All right, so in order for us to determine which transformations are happening, just by looking at the graphs, we can see here that the first transformation is a reflection in the y-axis. So the graph y is equal to f of x is reflected this way. All right. So this is the first reflection in the y-axis. So I'm going to write that down. All right. So the first transformation is a reflection in the y-axis. Now, after that, we can see that the graph shifts to the left by 1 unit. Okay. So this same graph now shifts to the left by 1 unit. So like this. Okay. So that's a translation. All right. So I'm going to write that down. That's number 2. So that's a translation represented by the vector -1 and 0. So basically 1 unit to the left. All right. Then what happens after that is, for us to produce the graph shown, it is now stretched. Okay, so that's a vertical stretch, and that's a vertical stretch of factor 2. All right. So if you look at all the y coordinates, they're being multiplied by 2, basically, to produce the graph of y is equal to g of x. So it's like we have this graph. Okay, let me just remove this first. All right, so it's like we have this graph of y is equal to f of x. So when this graph is stretched vertically, we can see that it takes up the shape of y is equal to g of x eventually. Okay, so that's a stretch and factor of 2 and parallel to the y-axis. So these are the 3 transformations going on. Now, on part B, they say, find an expression for g of x in the form a of f of bx plus c, where a, b, and c are integers. Okay. All right, so we are starting with y is equal to f of x, right? And under the first transformation, okay, transformation 1, what's happening is it is being reflected in the y-axis. All right, so a reflection in the y-axis is y is equal to f of minus x. Okay, that's how it is represented. All right, next, the transformation that comes is a translation. Okay, a translation here, and that's a translation represented by -1, 0. So it's a shift to the left by 1 unit. Okay, so we're saying that the whole reflected graph, okay, is undergoing transformation 2, where we'll write that as y is equal to f of minus of, and what's happening to x is being shifted by 1 unit. So we put +1 inside the bracket. Remember, if you have y is equal to f of x plus a, it means that it's a translation by a units to the left. Okay, so basically minus a to the left, or minus a 0. So if you have a minus here, then inside the bracket it will be a plus basically. And we do that for horizontal shifts or translations. Next, we have a stretch of vector 2 parallel to the y-axis. So this is transformation number 3. And we're saying for that transformation number 3, since it's a stretch, so it's 2, it's a vector 2 stretch, f of minus of x plus 1, like this. So that is what we are getting. So that's g of x is equal to, and to write it in the form a of f of b x plus c, it will be 2 of f of, and we can expand brackets here, so it's minus x minus 1. So this here is the answer. So that's how we do it for this particular question. So on question number 6, it says, the first term of a convergent geometric progression is 10. The sum of the first 4 terms of the progression is p, and the sum of the first 8 terms of the progression is q. It is given that q over p is equal to 17 over 16. Find the 2 possible values of the sum to infinity. All right. Okay, so here it's a convergent geometric progression, and the fact that it is convergent would mean that the modulus of r should be less than 1. And we've been told in the question that the first term is 10, so a is 10. We've also been told that the sum of the first 4 terms of the progression is p. All right, so sum to 4 equals p, and that the sum of the first 8 terms is q, so sum to 8 is equal to q. All right. Okay, so we've also been told that q over p is equal to 17 over 16. So that's the information we have. And they want us to find the 2 possible values of the sum to infinity. All right, so what we're going to do here is we're going to use the fact that sum to 4 is equal to p. All right, and for sum to 4, we will go a, which in this case is 10, all right, of 1 minus r to the power of 4, and that's over 1 minus r. So that has to be equal to p. All right, so that's the first thing that we're going to look at. All right, secondly, we are going to look at the fact that sum to 8 is equal to q, which would be 10 of 1 minus r to the 8 over 1 minus r should be equal to q. So for the first equation, I'll multiply both sides by 1 minus r. So 10 of 1 minus r to the 4 is equal to p of 1 minus r. All right. And for the other equation, it's 10 of 1 minus r to the 8 is equal to q of 1 minus r. All right. So we have equation 1 here, and we have equation 2 here. All right. So since we have been told that q over p, okay, here, q over p is equal to 17 over 16, I'm going to say equation 2 divided by equation 1. And this would be 10 of 1 minus r to the 8 being equal to q minus, actually, of 1 minus r is divided by, so on the left side, we'll be having 10 of 1 minus r to the 4, and that will be over p of 1 minus r. All right. So we can see here that the 10s cancel out, and the 1 minus r's cancel out. So basically, on the right side, we have q over p being equal to 1 minus r to the 8, and that's over 1 minus r to the power 4. Now, q over p, we've been told here is 17 over 16. So this also has to be equal to 17 over 16. So we can cross multiply. So 16 of 1 minus r to the 8 is equal to 17 of 1 minus r to the 4, basically. So that's 16 minus 16 r to the 8 being equal to 17 minus 17 r to the 4. Okay, rearranging, we'll be having 16r to the 8 minus 17r to the 4 plus 1 equal to 0. All right, so from this stage, I'll say let y be equal to r to the 4, which therefore means that we'll be having 16y squared minus 17y plus 1 equal to 0. And we can actually factorize this thing that we got, and we can put 16y here and y, then minus 1 and minus 1. So we factorized it. So the possible values of y are 1 over 16 or y is equal to 1, which would therefore mean that r to the 4 is equal to 1 over 16. So the possible values of r will be plus or minus a half if we do fourth root of 1 over 16. And r to the 4 is also equal to 1. So r is equal to plus or minus 1. All right. But we know that since this AP is convergent, mod r should be less than 1. Mod r being less than 1, okay, let me just write that down. Since mod r is less than 1, which actually means r ranges from -1 to 1, we can therefore say that r has to take values plus or minus of a half. These will both do because they lie within range, but plus or minus 1 will not. So this is what we're going to take. R is plus or minus a half. Now the question says we should find the two possible values of the sum to infinity. All right, so for sum to infinity, we'll start when r is equal to minus of a half. The sum to infinity will be a. A was 10, right? A is 10. So it's 10. And that's over 1 minus of a half. So it's 10 divided by 3 over 2, basically. So that's 10 divided by 3 over 2. And that's basically 20 over 3. All right. And when r has a value of a half, we're saying that the sum to infinity will be 10 over 1 minus of a half, which would give us 20. So these are the two possible values of the sum to infinity. And that's how we do it. Let's move on to the next one. That's number 7. And it says, the diagram shows a metal plate A, B, C, D, E, F consisting of 5 parts. The parts B, C, D, and D, E, F are semicircles. All right, so I think you can see that here. And they also say the part BAFO is a sector of a circle with center O and radius 20 centimeters, and D lies on this circle. The parts OBD and ODF are triangles. The angles BOD and DOF are both theta radians. So on part A, given that theta is equal to 1.2, find the area of the metal plate. Give your answer. Correct to 3 significant figures. All right. All right. So we want to make use of the information given. All right. So they say here we should find the area of the metal plate. And that's given that theta is equal to 1.2. Right, so for us to find the area of the metal plate, we are going to start by finding the area of the two semicircles. All right, so we have this semicircle and this semicircle here. All right, so in order for us to find the areas of these semicircles, we have to know what the radius for each semicircle is. All right, so If we consider the radius, okay, this radius here, and here I draw a line that goes from O down to touch the radius and make a right angle with it. That line will split angle theta into two half thetas. So we have half theta here, and we have this to be the hypotenuse for this little right angle triangle that I've formed. So we can actually find the radius r here. Okay, so we can say that r, using trigonometry, r is equal to 20 sine of half theta. Okay, that's what r is. Okay, so basically r is equal to 20 sine of half, and theta is 1.2. So it's half of 1.2, which is 0.6. So r is equal to 20 sine 0.6. So on our calculator, 20 sine 0.6 would be 11.29. So 11.29 here. All right. So that's what the radius is. So we can now find the area of the two semicircles by saying, okay, area is equal to, and we have two of them, so that's 2 times, and they are semicircles, so that's half times pi times the radius squared, okay, which in this case is 11.29 squared. So that's how we find the area of the two semicircles. That's going to be plus. Now we need to find the areas of the two triangles. Okay, so for the triangles, okay, we have these two triangles here. And for the area of each triangle, we will use half side sine of the angle, right? So we have two of them, so 2 times, then half times the sides, 20 times 20, and that's sine of the angle theta, which is 1.2. So sine of 1.2. Okay. Next up, we now need to find the area of the major sector. So this major sector. So for this area, we have to know what this angle is. All right. And this angle is actually 2 pi minus 2 theta radians. So to get the area of the major sector, we'll say that's going to be here plus half the radius squared, which is 20 squared, and that's times theta, which we said was 2 pi minus 2 theta, which is 2 of 1.2. All right, so this is how we find the area of the metal plate. So I'm just going to do a calculation for the whole thing. And we get 1549.89. So we can say here to 3SF, that's 1550, and the units should be in centimeters, so that's square centimeters. So that's how we do it. That's the answer right here. Let's move on to the next part. That's part B. And it says, given instead that the area of each semicircle is 50 pi square centimeters, find the exact perimeter of the metal plate. Okay, so they're giving us a new piece of information. They're telling us here that the area of each semicircle, okay, we're given instead that it is 50 pi square centimeters. Okay, so let us consider that. Okay, I'm going to erase everything that we used in the previous one, because it's a different situation altogether. All right, and they've told us here that the area of each semicircle is 50 pi. So we have an area of 50 pi square centimeters here and 50 pi square centimeters. Okay, now if we have such an area, that means that we will also have a different radius. Okay, so we have to find what the radius is, and to find the area of each semicircle, we know that it is found by pi radius squared. That's the one that's equal to, actually, that's half of that, right? Because it's half a circle. It's equal to 50 pi. Okay. So um, we will get from here r squared to be 100. So r is equal to 10, basically. So r is 10 centimeters, which would mean that this whole diameter BD will actually be 20 centimeters. All right. So we have 20 centimeters for BD. All right. Okay. So that information is very important because now they want us to find the exact perimeter of the plate, of the metal plate. So the perimeter, okay, will be like, okay, let's start with the semicircles. So this semicircle, okay, BCD, and this semicircle DEF. Let's start with this two. All right, so for each one of them, we'll just say pi times diameter for the length of the semicircle, right? So we have 2 times, that's half, times pi d, okay, because the area of each one is half pi times diameter, so times 20, and that's going to be plus. Next, we now want the length of the arc. So we're talking about this major arc here. All right. So this whole arc here. And to find that, we need to know what this angle is. All right. Now, to find this angle, we can consider this triangle here. Okay, both of them. And you can see that they are now such that they're actually now equilateral triangles where each of the angles is 60 degrees. So we have 60 degrees here, and it's rather pi over 3. So pi over 3 and pi over 3 here. So this angle is 2 pi minus 2 pi over 3, which is 4 pi over 3. All right. So we have 4 pi over 3 here. All right. So to find the length of the arc for the major sector, we'll just say it's r theta. So 20 times 4 pi over 3. Okay, so that's going to be plus 20 times 4 pi over 3. All right. So for this, we can do the calculation. Actually, they say it's an exact perimeter. Okay, so that's here they cancel. So we have 20 pi plus 80 pi over 3. And we get from the calculation 140 over 3 of pi. So that's the answer right here. Let's move on. On number 8, part A, it says, express 3x squared minus 12x plus 14 in the form 3 of x plus a squared plus b, where a and b are constants to be found. All right, so we have 3x squared minus 12x plus 14, 3 of x squared minus 4x plus 14. So I factored out 3 for the first two terms. Now I'm completing the square, so that's 3 of x minus 2 squared minus 2 squared, okay, plus 14. So that's 3 of x minus 2 squared minus 3 times minus 4 is minus 12 plus 14. So eventually we'll get 3 of x minus 2 squared plus 2. So that's the answer here. Let's go on to the next part, which says the function f of x equals to 3x squared minus 12x plus 14 is defined for x being greater than or equal to k, where k is a constant. So on B, find the least value of k for which the function f inverse exists. All right. So they say that we have this function and the domain is x is greater than or equal to k, right? And for f inverse to exist, it means that the function has to be 1 to 1. All right. And if it is going to be 1 to 1, knowing that the shape of the graph is a U-shaped parabola, okay, and x is greater than or equal to k, it actually means that by the horizontal line test, we only need to have values from this value of k Since it's greater, going to the right. So it means that we do not need the other part of the graph on the left. So basically, the horizontal line test says that any horizontal line drawn should intercept the graph only once. So that can only happen when the minimum value that k can take is the minimum value, actually the minimum x value. All right. So the minimum x value, we find it from the completed square form, which in this case is we take 2 here. All right. So k has to have a value of 2. Okay, that's the minimum value that x can take to make this function 1-to-1 so that the f inverse of x exists. Let's go on to the next one. For the rest of this question, they say you should assume that k has the value found in B. So find an expression for f inverse of x. All right, so we'll take the function and we'll write it as y is equal to, let's use the completed square form. Okay, so this is what we're gonna make use of. Okay, and I'm placing it here. So that's the same function, right? But in the completed square form. So basically, we will say, I'll interchange the variables. So it's x is equal to 3 of y minus 2 squared plus 2. Then y minus 2 squared is equal to x minus 2 all over 3. So y minus 2 is equal to plus or minus the square root of x minus 2 all over 3. So y is equal to 2 plus or minus the square root of x minus 2 over 3. Okay, but considering the domain, okay, the domain is x is greater than or equal to 2 because we got k to be 2, right? And we know that the domain of the function is comparable to the range of the inverse, okay? So we're saying that this range, this inverse must also have a range that is greater than 2. And that can only, for this thing to be greater than or equal to 2, that can only happen, that can happen for 2 plus something, all right? So f inverse of x should be 2 plus the square root of x minus 2 over 3. So this here is the answer. Okay, let's go on to the next part. On part D, the question says, hence or otherwise, solve the equation f of x is equal to 29. All right. So the question is saying hence or otherwise. Let's use the hence. All right. It's f of x equals to 29. All right. And if we inverse both sides, we should have f of x being equal to f inverse of 29. All right, so for f of x, we have that. Let's use the completed square form of f of x. So this thing here. All right, and I'm going to place it here. And for f inverse of 29, we had gotten f inverse to be this, right? So we're going to make use of this, and I'm going to put it here. All right. So in place of x, we're going to put 29. All right. So that's going to be 29 minus 2. Okay, 29 minus 2 over 3. So that's like 27 over 3, which is 9. Square root of 9 is 3. 2 plus 3 is 5. So we have 5 on the right side here. And 3 of x minus 2 squared plus 2 is equal to this, all right? So that's x minus 2 squared is equal to 5 minus 2, 3. 3 over 3, 1. So we have a 1 here, which means that x minus 2, if we square both sides, we get plus or minus 1. So x is equal to 2 plus or minus 1. All right, so the possible values of x would be 2 minus 1, which is 1, or 2 plus 1, which is a 3. Okay, but x has to be greater than or equal to 2. Okay, that's the domain. So x has to be equal to 3. All right, since x the domain is saying that x has to be greater than or equal to 2. So this one has to be the answer. So that's how we do it for this particular question. Let's move on. Now we're on number 9. All right, and it says the diagram shows the curves with equations y is equal to x cubed minus 3x plus 3 and y is equal to 2x cubed minus 4x squared plus 3. So in part A, find the x coordinates of the points of intersection of the curves. All right. So points of intersection of the two curves. Okay, we're just going to equate the two equations. 2x cubed minus 4x squared plus 3 is equal to x cubed minus 3x plus 3. All right. Rearranging, taking everything that's on the right to the left, we will be having 2x cubed minus x cubed, that's x cubed, minus 4x squared plus 3x equal to 0. Okay, because 3 minus 3 is 0. And we factor out x, so we have x squared minus 4x plus 3 equal to 0. Okay, bracket here. Then that's x off, and we factorize this thing. So x and x, 3 and 1, minus and minus. So the possible values of x would be 0, 1, or 3. All right, so 0, 1, or 3. All right, so now that we have the 3 possible x coordinates, actually that's what they want because they just said x coordinates, hey? So x equal to 0, x is equal to 1, x is equal to 3. These are the 3 x coordinates of the points of intersection of the curves. And that's how we do it right here. So we're moving on to part B, and it says, find the area of the shaded region. Okay. All right, so to find the area of the shaded region, we will need to make use of the limits, okay? This value here of x, which in this case is 1, okay? Remember the intercepts we got were 0, 1, and 3, okay? So 0 is here, so this is 1, and the other intercept right here is 3, all right? So 3 here. Okay, so we're going to start by finding the area enclosed by this curve, okay, and subtract from it the area enclosed by the second curve to get the area required. So I'll say here, for the area, we'll do the integral from 1 up to 3. And for the first curve, that's x cubed minus 3x plus 3, all right? So let's make use of that. I'll paste it down here. Okay, and that's with respect to x, and that's going to be minus the integral from 1 up to 3. And we're saying for the other one, it's the 2x cubed. So 2x cubed minus 4x squared plus 3. All right, so I'm going to put it here. All right, so that's with respect to x. All right, so we are going to say here, this is the same as the integral from 1 up to 3, and we can combine these two. Okay, the limits are the same, so we can combine. Okay, I'm going to say x cubed minus 2x cubed. That's minus x cubed. Then I'll take minus 4x squared. So minus, actually it's minus of minus, so it becomes plus. So plus 4x squared. Then this, which is minus 3x. Then for 3 minus 3, we get 0. All right. So that's with respect to x. Now we can integrate, and we'll be having, integrating this, that will be minus 1 over 4 of x to the power of 4. And integrating this, we get 4 over 3 of x cubed. Then for this, we get minus 3 over 2 of x squared. And that's 1 up to 3. All right. Now, this is going to be, we're now substituting 3 minus a quarter of 3 to the power 4 plus 4 over 3 of 3 to the power 3 minus 3 over 2 of 3 squared. And that's going to be minus, substituting 1 into this, we get minus a quarter plus 4 over 3 minus 3 over 2. Okay, so that's going to be, simplifying this, we get minus 81 over 4. And here, 3 into 27, that's 9. Then, so that's going to be 36. Then in here, that's going to be 27 over 2 plus a quarter minus 4 over 3 plus 3 over 2. So let's do the calculation here. All right. And we get 8 over 3. So 8 over 3. That's the answer here. Let's move on. We're now on number 10. On number 10, it says points A and B have coordinates 4, 3, and 8 and minus 5, respectively. A circle with radius 10 passes through the points A and B. So on part A, show that the center of the circle lies on the line y is equal to half x minus 4. Okay. All right, so we have 2 points, all right, given, and they say that the circle has a radius of that, okay, and they say that this circle passes through the point A and B. All right, so let's have the circle here, and let's have the 2 points. Okay, we don't know where they are specifically. All right, so this is more like a sketch, right? So let's say the point A is here, and let's say the point B is here. All right. And so a circle passes through these 2 points, right? And the center of the circle, I'm going to call that, well, C. A has coordinates 4, 3, and B is 8 and minus 5. So remember, this is just a sketch. It's not an accurate diagram. Okay, I'm just showing that A and B are points on the circle, and the circle has a center C. Okay. Do we know what the coordinates of the center are? We do not. Okay, but we know that the radius is 10. Let's say the coordinates of the center are A and B. All right, and we know that the radius is 10. So also drawing a line that goes to B, it should be 10 like this. All right. All right, so the question now says we should show that the center of the circle lies on the line y is equal to half x minus 4. All right. Okay, so let's find the midpoint of AB. All right, so midpoint of AB, and for that, it's going to be 4 plus 8 over 2 and 3 plus minus 5 over 2. Okay, so that's basically, well, 6 and minus 1. All right, so this is what we have. So that's the midpoint right on here. Okay, now that we have the midpoint, we also going to use that midpoint of AB to say, okay, let's say the coordinates of A of C are actually X and Y. I think it would work better. So for C, okay, C here, the coordinates, let them be X, Y. So here we can use the fact that the gradient of, let's say the midpoint was M, okay? The gradient of the line MC should be equal to minus 1 over the gradient of the line AB. So let's see if we can make use of that fact, because it is a fact, all right? AB is a chord, and CM should be perpendicular to it, okay? Because M is the midpoint of AB, right? So the gradient of MC is y minus 1, so it's y plus 1 over x minus 6. All right, so here I'm using this and the coordinates of M, which is the midpoint, right? And this has to be equal to minus 1 over the gradient of AB. All right, so technically it's like minus. Let's use change in x on top since it's the reciprocal. So that's basically 8 minus 4, and that's over minus 5 minus 3. So here I'm making use of A and B, all right? So this is what we're having, all right? So we have y plus 1 over x minus 6 is equal to, then this is 4 over minus 8, which is minus a half with the other minus, so it's just a half that we got right here, and we can cross multiply. So if we cross multiply what we have, it's 2 of y plus 1 is equal to x minus 6, right? So it's 2y plus 2 is equal to x minus 6. So it's 2y is equal to x minus 8. Dividing both sides by 2, we get y is equal to half x minus 4. Okay? That's what they want us to prove, that it lies on the line. And we got that, the line from it. So we can say proved. Okay, let's move on. Now we're on part B. They say find the two possible equations of the circle. All right. So let's work on this. Okay, we have the circle, and we have been told of late on part A that the circle lies on the line y is equal to half x minus 4. All right. So that means that the center of the circle, since it lies on the line y is equal to half x minus 4, we can actually find the general like coordinates of the point of the center. Okay, so the general coordinate of points on the line, for that I'll say let x be equal to k, which means that y will be half k minus 4. Substitute that into this, all right? Which therefore means that they are k and half k minus 4. So to help us find the equations of the circle, we have to know what the center is, and here we're saying that generally for the center, the coordinates will take the form k and half k minus 4. All right. But we also have other points, like we have a point A, which is what did we say? Was it 4, 3? 4, 3, yes, it is. A is 4, 3, and a radius from the center to center C to A would have a length of 10. We've already been given that, right, in the question. So basically, we will be saying, if we say 10, the radius squared, it would be equal to 4 minus, or let me do it this way. Okay, x coordinates, k minus 4 squared, and plus a half k minus 4 minus 3, and that's squared. All right, so that's 100 is equal to k squared minus 8k plus 16 after expanding this. And this is actually half k minus 7, right, squared. So it's, if we expand that, we get a quarter k squared, and that's minus 7k, and that's plus 49. All right, so we have 100 being equal to k plus a quarter k squared, which is 5 over 4k squared. Then minus 8k minus 7k is minus 15. Then 16 plus 49 is 65. So that's plus 65 here. All right. So rearranging, we'll be having 5 over 4k squared minus 15k, and 65 minus 100, that's going to be minus 35, equal to 0. Let's multiply everything by 4 over 5. So it's 10 by 4 over 5 by 4 over 5 by 4 over 5 by 4 over 5. And if we do, we will get k squared here, and this is going to be minus 12k, and that's minus 28, equal to 0. So we can actually factorize this. This is k, this is k. And let's use 14 and 2, so minus and plus. So the possible values of k are 14 and minus 2. Okay, so we therefore have the two possible centers, which would be, okay, remember the center is k and half k minus 4. Okay, so when k is 14, then center would be 14 of half of 14 minus 4, which is 14 and 3. And when k has a value of minus 2, c will be minus 2 of and minus 5, basically, like this. All right, so it therefore means that the equations, if we have a center with coordinates 14, 3, then that will be x minus 14 squared plus y minus 3 squared is equal to the radius squared. The radius is 10, so it's equal to 100. And when we have the center minus 2 and minus 5, that will be x plus 2 squared. Y plus 5 squared is equal to, again, 100. So these are the two possible equations of the circles. That's how we do it. Let's move on. Now we're on the last question, number 11. And it says the equation of a curve is y is equal to kx to the half minus 4x squared plus 2, where k is a constant. So on part A, find dy by dx and d squared y by dx squared in terms of k. All right. So let's start with dy by dx, which would be half of kx to the power of half minus 1, which is minus a half, minus 8x. And for d squared y by dx squared, that's going to be minus a quarter k x to the power of a half. Actually, minus 3 over 2. Okay. So minus 3 over 2, minus 8. So that's what we're getting here. Let's go on to part B. It says, it is given that k is equal to 2. Find the coordinates of the stationary point and determine its nature. Okay, so when k is equal to 2, dy by dx will be equal to, that's going to be half of 2, so that's 1. So it will be x to the power minus of a half minus 8x, and at the stationary point, this has to be equal to 0. All right, so we have x to the power minus of a half is equal to 8x. All right, and this is like x to the power of a half is equal to 1 over 8x. All right, if we invert both sides and square both sides, we'll be having x. Okay, if we square here and we square here, we get x being equal to 1 over 64 x squared. And if we multiply both sides by 64x squared, and here 64x squared, we will be having 64x cubed being equal to 1. All right, so x cubed is equal to 1 over 64. So x is cube root of 1 over 64, which is 1 over 4. So that's what we're getting x to be. The nature of the stationary points, we're going to use the second derivative. Okay, so the second derivative goes like this, all right? So for d squared y by dx squared, we will be saying, okay, remember k, they have said that k is equal to 2. So k is 2 and x is a quarter. Okay, so therefore, the second derivative will be minus a quarter k of a quarter to the minus 3 over 2 minus 8. So that's like minus a half. And simplifying this part, we get 4 to 8, we get 8. And that's minus 8. So that's like minus 4 minus 8, which is minus 12. And minus 12 is less than 0, which therefore means that this has to be a maximum. All right, so let's see. The question was saying we should find the coordinates of the stationary point. Did we find it? We actually got the x value. So the y value, all right, we hadn't gotten that. To get the y value, we simply go to the original equation, kx to the half, okay, which is 2x to the power of a half, and minus 4x squared, so that's minus 4 of a quarter squared, and that's plus 2. So plus 2. So we need to move this a little, and here we get y to be 1 minus a quarter plus 2, which is 11 over 4. So 11 over 4. So therefore the coordinates of the stationary point are a quarter and 11 over 4. So that's the answer. And then for the nature, we got that's a maximum actually. So that's the answer as well. So that's how we do it here. Next, there's a part C. And part C says points A and B on the curve have x coordinates 0.25 and 1 respectively. For a different value of k, the tangents to the curve at the points A and B meet at a point with x coordinate 0.6. Find this value of k. All right. Okay, so we have the curve and we have points A and B, all right, which have coordinates, x coordinates 0.25 and 1, all right. And then they say for a different value of k, the tangents to the curve at the points A meet at a point with coordinates. Okay, so we have a tangent at A here and another tangent at B here. All right. And they say this is A, this is B, so they meet at another value, which is an x value of 0.6. So let's say this is the x-axis. This is a sketch, okay, just to illustrate, just to make a sense of what we have. This is 0.25, and this is 1, okay, according to what they've told us. So they're saying we should find the value of k, all right. Okay, so let's work on this. The curve has equation y is equal to half k. Okay, what did it say? That's half. Actually, it's kx to the half. Okay, so it's kx to the power of a half, and that's minus 4x squared plus 2. Is that right? Minus 4x squared plus 2. Okay, that's right. So that's the equation of the curve. All right, and we had done dy by dx already, okay, the gradients. So dy by dx was this. So we're going to make use of this. So we already have the gradient function. Okay, so when x has a value of 0.25, the gradient will be half k of 0.25 to the power of minus of a half minus 8 of 0.25, which will simplify to k minus 2. Next, when x has a value of 1, dy by dx will be what? It will be a half k minus 8. Okay, so these are the gradients, okay, at A and at B. All right, so next, we need to know that when x is 0.25, what is y? So when x is 0.25, y will be, okay, that's k of 0.25, the power of a half, minus 4 of 0.25 squared plus 2, right? So y will be half k plus 7 over 2. That's what y will be. All right. And when x is equal to 1, y will be, okay, y will be just k, then that's minus 4 plus 2, so that's minus 2. Okay, so we are saying here that the coordinates of A will be 0.25 and half k plus 7 over 2. And at B, that's 1 and k minus 2. And that's plus 7 over 4. And we're also going to say when x is 1, what is y? Okay, when x is 1, substituting into here, we will get that y will be k, and that's k minus 2. All right. So we are saying that the coordinates of A are 0.25 and half k plus 7 over 4. And the coordinates of B are 1 and k minus 2. So the equations, okay, the equation of the tangent at A will be y minus half k plus 7 over 4 is equal to the gradient at A, which we got to be k minus 2. So k minus 2 of x minus 0.25, okay, which is a quarter, right? So this is what we have for the equation of the tangent at A. And for the equation of the tangent at B, we'll say here y minus the y coordinate k minus 2 is equal to m, the gradient. Now the gradient at B, we say that that's half k minus 8, right? So we have half k minus 8 of x minus 1, basically. All right. So this is what we are having here. Now, we are going to say since at the intersection of the tangents, okay, the intersection of the tangents, that is here, the value of x is 0.6. We can equate the two equations, all right, and substitute 0.6 for x. So if we take this equation, okay, all right, and make y subject, we'll be having k minus 2 of x, but x is 0.6, of 0.6 minus a quarter, that's 0.25 basically, and that's going to be plus this, that's half k plus 7 over 4, okay, and it's equal to the value of y here, all right? So that's half k minus 8 of x, which is 0.6 minus 1, and that's plus, okay, here I was supposed to put a bracket, right? Okay, yeah. So it's going to be plus k minus 2. Okay, so I think it's now better. All right, so we now can simplify what we got. All right, so 0.6 minus 0.25 is a fraction is 7 over 20. So we have 7 over 20, all right, and that's off k minus 2, and that's plus half k plus 7 over 4, and that's equal to here 0.6 minus 0.1 is minus 0.4, which is minus 0.4, which is minus 2/5, and that's off half k minus 8, and that's plus k minus 2. So we simplify, so we get 7 over 20 of k minus 7 over 10 plus half k plus 7 over 4, and that's equal to, here we get minus a fifth of k plus 16 over 5 plus k minus 2. Rearranging, we'll be having 7 over 20 of k plus half k plus a fifth of k minus k equals to the numbers 16 over 5 minus 2 plus 7 over 10 minus 7 over 4. Okay, so simplifying the left-hand side, we get 1 over 20 of k, and on the right side, we get 3 over 20. All right, so basically, if we multiply both sides by 20, we get k to be 3. So that's the answer right here. And that's how we do it. And that does it for this paper.